Okay, day 1, arcs, central angles, and inscribed angles. So in arc measure, let's start there. So the measure an arc creates is at the end of the circle, in center of the circle. And this will be represented in degrees. So if this is my central angle, 100 degrees, then the arc measure angle here is also 100 degrees. That takes us right into central angles and arc measures. The central angle is congruent or equal to its arc. So if angle ABC is 110, then arc AC equals 110 degrees. Okay, arc addition postulate says the measure of the arc formed by two adjacent arcs is the sum of the measures of the two arcs. For example, if I had arc CD plus AD and this is 90 degrees, 32, that'll be 122 degrees. Then arc AC is also 122 degrees. Inscribed angles and arc measures. An inscribed angle is half of its arc, or the arc is 2 times the inscribed angle. For example, arc AC would be 168 degrees and angle ABC would be 84 degrees. So if this angle is 84, it's an inscribed angle, it's on the circle, then the arc is twice that, so 84 times 2, 168. If I just gave you 168, then you could find the arc angle by dividing by 2. So similarly, oh, this is mislabeled here. So arc AC would be 110 degrees because it's a central angle, and then interior angles. Okay. So let's start with the algebra here. So it says name the type of angle shown and find the requested measure. So here we have angles that are created using the center. So these would be central angles. Okay, and we also have these smaller arcs that we're using, so I could call that minor arc. So right now I've been given these 2 arc measures, and I want to find X and arc LK. So right now, given these 2 arc measures, together they create a semicircle because LJ is a diameter. So what I'm going to do is I'm going to add these up and set them equal to 180. Combine like terms. 17 plus 5 is 22x. Negative 41 plus 23 is negative 18 equals 180. 180 plus 18 is 198 divided by 22, so x equals 9. That was one of the answers I needed. And the other answer was arc LK, so I'm going to plug 9 in for x. So 17 times 9 minus 41. I got 112 degrees. So LK as an arc is 112 degrees. Number 2, find arc BC. So here's our arc. I'm asking you to find BC, so this is what we're missing. I can do that right now. AB is a diameter. So I can find arc AC by taking 47 times 2. This is an inscribed angle. Okay, so 47 times 2 is 94. Yep, 94. And this arc here would be the other half of the diameter, so I'm going to take 180 minus 94, and I get 86 degrees. So BC equals 86 degrees. Number 3, we want to find X, arc WX, and arc VXW. So all of these are created using the center, so I'll say these are central angles. Okay, so right now I know that this is 90, which means that this is 90, and these are all missing. So what I'm going to do is I have all parts of the entire circle, so I'm going to go ahead and add all of these up, set it equal to 360 all the way around the circle. So first, starting with my x's, 8x plus 21 plus 10. 39x. And then my whole numbers, 90 minus 12 plus 9 is 87 equals 360. 39 equals 273. And divide by 39, x equals 7. So that's one of the things I needed. I also need WX and VXW arcs. So to find arc WX here, I'm going to plug in 7, so 21 times 7 minus 12. And I got 135. And I want to find VXW, so V to X to W. So two things, I could either plug it into 8x and subtract from 360. So 8 times 7 is 56. Then I would just do 360 all the way around a circle, minus 56 and get 304. The other way is I could have plugged it into here. And then added these three up. Number 4. So here I have an inscribed angle. The angle is on the circle. So inscribed angle. I was told that this angle is 7x minus 10. And I have these two arcs, and arc AC would create a full circle. So what I'm going to do here is find arc AC, 360 minus these two, 92 minus 162. I'm getting 106. Okay, I know that the inscribed angle here is half of 106. So this would be 53 degrees. Then I'll set this equal to 53 degrees. So 7x minus 10 equals 53. 7x equals 63. X equals 9. Number 5. Find angle ADC and arc AD. So angle types, none of these angles are touching the center, so these are all inscribed angles. So right now I need to find, let's find arc AD. We can find that because we know all the rest of the circles. So I'm going to take 360 minus these three things. So 360 minus 39 minus 61 minus 147. And I'm getting 113 degrees. So AD, arc AD is 113 degrees. And I was asked to find angle ADC. So ADC, this angle here. So first I'll find arc AC. Arc AC is 39 plus 61, which is 100. And I know this inscribed angle is half that, so it's 50. So angle ADC equals 50 degrees. Number 6. Again, we have an inscribed angle. So let me set this up a little bit differently. So we know that the angle equals 1/2 of the arc. So the angle is 8x minus 9, and that equals 1/2 of 158. That's another way we could set this up. Or you could just divide 158 in half right now, find that number, and set 8x minus 9 equal to that. 8x minus 9 equals 158 times 1/2 is 79. 8x equals, add 9 on both sides, and you get 88. Divided by 8, x equals 11. Number 7. We want to find the measurement of angle WXY. So we have an inscribed angle. Pretty quick on this one. We're just going to go ahead and take 62, divide it in half. So this would be 31. Number 8, inscribed angle. So I know that, and I could set this up two ways. I could say the angle equals half of the arc, or I could say 2 of this angle equals the arc. Either way works. So I'll kind of show both ways working this out, and you can decide which one you like best. So the first is the angle 67 equals 1/2 times the arc for x plus 58. And the other is 2 times the angle equals 4x plus 58. So here, 67 equals 2x plus 29. Subtract 29, so 38 equals 2x. Divide by 2, so x equals 19. Over here, 2 times 67 is 134. Subtract 58. Divide by 2. Or sorry, divide by 4. Either way will work. Just got to find the pattern that you like to use. I typically go for angle equals half of the arc. Number 9. So this one's got a lot going on. We're finding a lot of different measurements here. So all of these, the angles are created using the center. So these are all central angles. And I need to find my measurements. So one thing I'm noticing right away is that QS is a diameter and UR is a diameter. That helps me because it creates multiple 180 degrees. So right now, if I cover this up, I see that I have a semicircle. So right now I can find QR because it's 180 minus 25. So QR is 155 degrees. Then I could find, if I cover these up, I could find UQ because it is 180 minus 155, which in turn is 25 degrees. So you kind of see that they've created vertical angles in here. Okay. Then lastly, I can find this angle here one of two ways. I can cover these up and say, okay, it's 180 minus 44 minus 25, or cover these up, it's 180 minus 44 minus 25 that way. So TS is 111 degrees. Now let's go through. TQ. So T to Q, I take 44 plus 25 and get 69 degrees. QR, Q to R is 155. TS, 111. Okay, so this is a major arc, so SQR. S to Q to R. So all of them except for SR. So 360 minus 25, 335. In arc RQT, R to Q to T. I'll add those up. So 155 plus 25 plus 44, 224. Last one for today. It says in circle E, measurement of angle ABD. So this angle is 6x plus 26, and measurement of angle ACD, this angle here, is 13x minus 9. Find arc AD. So one thing that we're seeing here is that both of these arcs, if I kind of outline this, angle B here is opening up to arc AD. And then angle C here is also opening up to arc AD. So they overlap, and actually they have the exact same arc measurement, which means that those angles are the exact same measurement. So what I'm going to do is I'm going to set these two things equal, solve for x. So that's 13x minus 9 equals 6x plus 26. Subtract 6, so 7x equals, add 9, so 35. Divide by 7, so x equals 5. So here's some little bit of critical thinking. I was asked to find arc AD. First, I need to find the angle. So I'm going to find this angle that's 6 times 5 plus 26. 6 times 5 plus 26, that is 56 degrees. And I know that the arc is twice that, so times 2. So it's 112 degrees. So arc AD is 112 degrees. So you may want to write yourself the note, same arc, inscribed angles are the same. Or equal.